Okay, we're in section 9 of the notes. This is polar coordinates and parametric equations. The hope, again, is that you're paying attention during lecture and you understand what's been presented to you. All right. After you do that, do supplemental exercises, and then, of course, do the web assign. Also, try to say something productive in the discussion group if you can. So, what do? We discuss the parametric equations. All right. We went through some examples. Typically, we used a parameter t to use an indication of time. And we did some, elimination of parameter, and we did some plotting of points, and we came up with pictures. All right. Fairly simple stuff. All right. So, after doing that, I guess I did talk a little bit about technology. And I want to point out that for the most part, if it's simple, we want to do it by hand. But if it gets to be difficult, understanding how to use technology would be a good idea. All right. And again, we did some plotting points. We also use technology. The software that I'm using for some of these problems was Grapher. Other times I'm using Wolfram Alpha. Other times I'm using Sage. All right. So I also point out what happens with a lot of students is they get tricked easily because they're not thinking, or maybe they're not mature enough to think through the problems as we would like you to try to think through those problems. That really requires you to, carefully, people do make mistakes, but carefully think about what you're being presented. We did go through an example where people get tricked. No, we're not trying to trick you. All right. Software doesn't get tricked, by the way. It typically doesn't get tricked. I talked about using a software called Mathematica. Um, I'm going to say for the most part, really, not using Mathematica at Essex anymore because it's got to be too expensive and students weren't using it. So we're going to be using Alpha. And so this would be the Mathematica code here. We talked about this in class, and we talked about the Sage code as well. I'm sorry, not Sage code, but the Wolfram Alpha. I kind of like Wolfram Alpha because it's easy. All right. We did some interesting graphs over there too, something like this over here. And we'll go through that again with when we do the homework. We did the polar coordinates. Again, that's where we have a coordinate system where we're given a radius and a theta. The radius is now a directed distance from the pole or the origin, and theta is a standard position angle. All right. So we talk about Cartesian relationships, how we convert back and forth. We talk about what polar graph paper looks like. This would be superimposed on top of an XY coordinate plane, and it makes it easier for some students to locate points. And we did discuss that. Then what do? We talked about graphing, basically a variety of methods. Again, I'm a big fan of Wolfram Alpha for graphing, at least for this material here, because it's easy. Graphic calculators can also be used. That includes your cell phone. If you have a computer running OS 10, I would recommend looking at Grapher. Grapher is a great application. Again, I can't go say something. Wolfram Alpha is really it's a great application for doing problems. If you're running on a Windows PC, a lot of students have told me that WinPlot is good. Give it a shot. If you're using a Unix machine or a Linux machine, probably you don't need to be told what to use. You probably have a good understanding how software is used now. All right. So we gave some examples where we went back and forth between, looking at it, a foreign looking graph and then converting it back to a Cartesian. Again, you could be tricked by doing that. And again, our intent is not to try to trick you. All right. We did graphs. We did a bunch of graphs. All right. We did plotting of tables. What a nightmare that is, but people do it, especially if they get stuck. We talked about families of polar curves. No, not a lot of memorization here. We're going to try to reason through these problems over here. Again, they were given some kind of families over here. Again, we're not asking to memorize that. All right. Then what do? We eventually got to these examples over here. And let me get to that. And we did them. We did those examples in class at the whiteboard. All right. For those students that have trouble following, there's also embedded videos in the notes. You're more than welcome to look at those videos. There's also nice pictures in the notes. Those pictures represent what we did in class. All right. So we went through a bunch of those examples. And again, we're hoping you took time to learn that material and to review that material. All right. So what I want to do is I want to go to what you expect to do now, which is after doing all that work, you get to supplemental activities. Again, I can't say it's enough. It's important you start thinking about reading textbooks. All right. And again, it depends what your skill set is, but you might have to go back and read more basic textbooks, like maybe a textbook on algebra, all right, or maybe a textbook on pre-calculus, whatever. But you can move forward in your education by reading books. It's important you do that. The book that we're dealing with is in your WebAssign course. All right. So when you go to website, you'll see a book there. You can read that. Basically, any book is fine in trigonometry. We're doing homework now. So I'm going to be switching to the whiteboard. As I switch to the whiteboard, the notes are going to disappear. All right. Now, when I say they're going to disappear, they should be in your possession, but they're no longer going to display on the screen. I'm just going to go right to the whiteboard. I'm going to get my iPad. I'm going to do another share with you. And I'll work through the problems. Okay, so again, I want to remind you where we are. We're in section of 9 of the notes, section 9. And we're doing the homework. The expectation is you've already done the homework, all right? And if you're watching these things, you're kind of curious about how to do a particular problem, or maybe all the problems you're curious about. How would I have done the problems? So I'm going to put down number 1 for you. Again, we're in the homework, and we're in section 9. And what they gave me a parametric function, right? They're saying x is a function of t. Now, t is typically time, but it doesn't have to be. And what is it? It's just equal to t. And then they say y is also a function of t, but it's a different function. I'll call it g. And what is it? Well, it's 3t cubed. All right, so I want to kind of read it. It says graph it. And I want to point out, you could do tables. I'm not going to say you can't do tables. Like if you did tables over here, you're graphing x and y, but you also need to know what t is. And you'd pick some simple numbers for t. For example, if you chose 0, -1, and 1, yada, yada, yada. I'm not opposed to using tables. It's fine. You can do it. All right, tables are helpful. You're going to learn a lot by doing tables. So for example, if I chose 0, what would you get for y? 0. What do you get for x? 0. That was pretty simple. If you chose, -1, for x, what do you get? You get -1. And what would you get for y? -3. Oops, I'm sorry. I jumped the gun there. Let me get my eraser out. Okay, let's keep going. And if I chose 1, what do I get? I get 1 and 3 now. Now, granted, somebody says, I don't know what you're going to do with that. Well, you could plot those 3 points. 0, 0 is easy, right? And again, this is the x-axis, and this is the y-axis. And what do you get? -1, -3. And then 1, and then 3. Unfortunately, for a lot of students who are looking at that, and it's really, I'm not saying you can't draw a straight line through it. Go to town, draw a straight line through it. It seems unlikely that it's a straight line. So what I want to do is, you can continue to plot points, but I don't want to continue to plot points. What I want to do is, I want to eliminate the parameter, right? Because if I do that, maybe it'll be easier for me to plot it. And so let's write this down. We know x is t, and we know y is 3t cubed. And what I'm going to do is, I'm going to plug this in here by eliminating the t in the problem. So what's t? Well, t is just x, so it's going to be 3x cubed. Well, I know what that looks like. It's a cubic problem. And I'm going to put that down for you now. The cubic problem is going to look sort of like this over here. Not a line, a cubic function. All right, have we done cubic functions before? Of course we have. Now, granted, somebody says, I think the graph of a machine would do better, and it does. It certainly makes a better graph, but this is sufficient. This is sufficient for a cubic. But again, if you look at the graph, it would be figure 82. And they do have a better looking picture over there. All right. What does B say? B says eliminate the parameter. That's done right over here. That's done. Now it says, basically write down the domain and range of this problem. And that's going to be an x. What's x? X can be any real number. If you prefer notation like this, that's fine. And what's the y? The y could also be any real number. And why is that? Look at your picture. What's that going to be? Minus infinity to infinity. All right. Fairly simple question. And they do put that down for you. All right, let's go to number 2. Kind of reading it. And what's number 2? And again, it's a parametric. And what do you got? X equals 3 plus 4 cosine of t, and then you get y equals 5 plus 4 sine of t. This should remind you of something we've done in class. They want you to graph it. And again, I'm not saying you can't do it. You certainly can take points. How do you take points? Pick values for t, evaluate the function, x is a function of t, evaluate the function for y is a function of t, and you would plot a bunch of points down. What I want to start doing is realizing that we've done something like this before. So I still want to limit the parameter, but I don't want to solve one of these things for t and try to do that. It seems like maybe too much work. I'm going to say it's probably going to be easy. So I'm going to write this thing as x minus 3 over 4 is equal to cosine of t. Now, by the way, someone says you could solve for t. I'm not saying I can't. I don't want to, though. I just want to get t on one side and x on the other side. And then you square both sides. What'd you get? X minus 3 squared over 16 equals cosine squared. This reminds you of something we've done in class already. Let's do the y. What do you get for y? Y minus 5 over 4 would be the sine of t. I'm going to square both sides again. What do you get? Y minus 5 squared over 16 equals sine squared t. All right, what am I going to do now? Add these two equations together. So what do you get? X minus 3 over 16 plus y minus 5 squared over 16 equals cosine squared t plus sine squared t. Now, what would this give me? I hope you realize the right side is just the number 1, right? If just the number 1, I'm going to multiply both sides by 16. What do you get? X minus 3 squared plus y minus 5 squared equals 16. Well, at this point, you should recognize that this guy over here is actually an equation of a circle. Whoops, LA. All right. This is an equation of a circle. It's still a circle. What's question number 1? Graph it. I'm ready. All right, let's put this down for you. And we'll look at the key later. What's the center? I'll write this down for you. The center is going to be 3, 5. Let me do that for you. 1, 2, 3, and then 5 up. Put the center down for you. All right. What's the radius? The radius is 4. All right, let me do that. I'm going to say the radius is 4. Maybe something like this here. 4 down. Let's see, 4 up. Let's go 4 to the right over here. 4 to the, to the left and 4 to the right. I'm never good at drawing circles, by the way, but it doesn't really much matter to me. Right. I want to put the points down for you, though. This is why do you do that? You need to do that. And what's that point over there? Well, it looks like 3, right? And then, the question is what's the y coordinate? Well, 1. Pretty simple to do. All right, put this point down, and this point down. Put this one over here. And what do I know about that? I know the y coordinate's 5. And I'll put this one down. I know the y coordinate's 5. The question is, what are you doing? The center's at 3, but you moved over 4, so it'll be 7, right? Now, if the center's 3 and you're moving left 4, this would be minus 1. All right, put this point over here. And I know the x there is 3. And what's the y going to be? Well, I'm at 5, but I'm at 4, so it'll be 9. All right. So I'm going to keep looking through the questions. And as I do that, I do notice that it give me a graph. It's figure 83. Yes, I like their picture better. I want to look at it, though. I want to see if I got it, relatively speaking, correct. I'm seeing the 3, 1. I'm seeing 7, 5. Yep. And then I'm looking at the points, 3, 9. Yep. And I'm looking at minus 1, 5. Yep. And again, I'm looking at this thing over here and I'm agreeing with the graph. All right. So, what's number 2 questions? Eliminate the parameter. I've done that. It's right over here. Let's take a look at their answer key and let's see what they got. X minus 3 squared, y minus 5 squared. Yeah, they got that. Where they want to know the domain and range of this thing over here. Let's write this down. I'll write the domain down. And the domain are x values. And what do the x's go between? Well, looking at my picture, looks like it goes between minus 1 and 7. What's the range of this thing? Well, again, I'm looking at my picture. My picture's not great, by the way. But what's the lowest the y could be? 1. What's the highest it could be? 9. Let me look at the key, see what they said. They said y is between 1 and 9, and they said the x between -1 and 7. I feel really good about that. All right, let's put number 3 down. I'm going to move this up. Again, this is homework. Hopefully you've struck with this before. And what they say, it says a point in polar coordinates is given. Now they're reminding you, polar coordinates going to be r, comma, theta. And what's the point going to be? 2, comma, minus pi over 4. So I know the r is 2. That's a direct distance from the pole. And I know the angle is minus pi over 4. It says find a corresponding rectangular coordinate for the point. Well, what I'm going to do is I'm going to draw the picture of it. And I want to remind you what I'm doing over here, what we told you to do in class. The first thing we told you to do in class is concentrate on this thing first. This is the angle. What's the angle going to be? Well, I'm looking for that line, right? This is going to be the line where the pole is going to be on that goes clockwise minus pi over 4. And that line's going to look like this over here. All right. So I know that this is the angle. I'll write this on over here, minus pi over 4. Now, by the way, there's an infinite number of coterminals with that, but I'm not asked that question. What I'm asked about is, where's the point? Well, now we need to go in the direction of this line. And this we're talking about, minus pi over 4. It's over here. How far? We need to go 2 units in that direction. Now we have to find a circular radius 2 now, and I'll just simply say this over here. All right. So what I'm going to claim over here is that we're going out 2 units from the pole. This is the pole in the direction of minus pi over 4. All right. So here comes the question. What's the coordinate in the XY system? Well, that's not so bad. And I notice this thing is like a triangle, right? So I know the x coordinate is positive, and I certainly know the y coordinate is negative. So it's a reference triangle, right? I'll put this over here. 45 degrees. 1, 1, root 2. Right? What do I mean by that? I'm looking at this triangle over here. But you know what? I don't want it to be root 2. I want it to be 2. So I'm going to multiply everything by root 2. Make it bigger now. Yeah, that doesn't look right. Multiply everything by 2. I'm doubling its size. By root 2, I mean, not doubling its size. I'm sorry. Root 2 times root 2 is 2. This should be root 2. This should be root 2. It's still 45 degrees. All right. So what's the x coordinate? I'll write that down for you. Root 2. What's the y coordinate? Minus root 2. Put a box in this. I'm going to look at my answer key. See how we did. We did great. I'm seeing it right over there. All right. Okay, let's keep going. And I'm going to, the next one looks pretty interesting. I'll put number 4 down. And number 4, where they give me, they say plot the given point in rectangular coordinates. Find 2 sets of polar coordinates. Oh, so this is a rectangular coordinate. So I'll write this one. It's 8 root 3, comma, minus 8. What does that mean? It's rectangular. This is the x, and this is the y. All right, plot it. Well, it doesn't look too bad. And I got to be careful about this. And I know the x is a positive number, right? The x is a positive number, and the y is negative. Now, looking at those things over there, I'm going to say 8 root 3, maybe over here somewhere, and then minus 8, maybe over here somewhere. So I guess that's where the point is. I'm going to just put down for you. 8 root 3, whoops, made a mistake. 8 root 3 minus 8. All right, I'm going to draw this picture in. So I put the line down over here. But again, what I want to get across to you, the reason I put the line over there is, I know where that line goes through that point, right? Question is, I wonder what the angle is. It's got to be easy. It really does. It has to be easy. All right. Now they want the angle. I'll write this on the side for you. They want the angle theta to be between 2 pi and 0. All right. So I want to point out the easiest one for me to do is this one right over here. All right. Of course, what I want to do is I want to get the reference angle. I'm looking at that. It looks sort of familiar to me. And I'm kind of looking at it, and I'm going to say, looking at it, I see the root 3 in it. So I'm going to say probably related to something I've seen before. And I put this down for you. I think we've seen these before, right? Very bad in a semester. Let's see, 2, 1, root 3. Well, I guess I'd multiply everything by 8, right? 8, 8, and what's 8 times 2? 16. So what's the angle over here? If I looked at it, it's 360 minus 30, which is 330 degrees, right? What's the R? This is the angle theta, by the way. What's the R? It's 16. Again, I'm looking at this over here. So I'm ready to write it down. Remember, it's written down as R, comma, theta. We'll look at the key later. What's the theta? 330 degrees. That's 11 times 30 degrees. 30 is pi over 6. So it's 11 times pi over 6. So it's 11 pi over 6. What's the R? 16. I'm going to say that's one answer. They want 2. So the other one I'm going to take is, I'm going to take this one over here now. Okay. And so I wonder what that is. Well, I'm looking at it, and I'm going to say, looking at that thing, again, pictures are nice because they help me with it. I'm going to say the angle over there now is not 330 degrees. What's it going to be? This angle theta, I'm talking about the blue line, not the black line, right? Or the curve there. You should the kind of rotating around. What's that going to be? 150, right? And what's that in the radian measure? Well, let's take a look at that. That would be 5 times, right? 30 degrees. And 30 degrees is pi over 6. We'll look at the key later. So I'm going to say 5 pi over 6. Still on that line, by the way. But the direction we have to go in is, well, if you're looking at this thing over here, we're on this thing here in that direction. We need to go in the opposite direction. So it's going to be minus 16 now. It's a directed distance. Let me write that down for you. Put a box in this. I'm going to go to the answer key and see what they have written down over there. And they have 16, 11 pi over 6, minus 16, 5 pi over 6. I feel good about that. Let's keep going. I'm going to go to number 5 now. And what's number 5 say? Convert the polar equation to rectangular form. Whoa. Okay. A lot of students are still confused by the radian measure. There's no degree symbol in this, or no like revolutions or rotation. I'm just going to, basically, not that I have to, but it would be nice to know the degree measure of this as well. And again, it's more common language. Pi's would cancel off. 3 goes into 180, 60. Well, 2 times 60 is 120 degrees. All right. I'm still confused. Let's read it. It says convert the equation. Oh, it says drawing a picture might be worth 1,000 words. Let's do that. Well, the only thing I know about this picture over here is that the angle is 120 degrees. So I'm going to say if I were to rotate, it would look sort of like this over here. Now, what's the R? Could be anything. This is 120 degrees, right? The R could be anything. Question if it could be anything. What is that thing? It's a line. That's all that thing is. It's a line. So if you were to graph this thing out over here, it would look like that line over there. All it says is theta is 120 degrees. It's a line. It doesn't say what R is. Question is, what's the equation of a line? Y equals mx plus b. And write that down for you. What's b? Clearly 0. So the equation of this line is y equals mx. Now I got to do this. I'm going to draw my triangle over here. What's the reference? Again, not saying these are terribly good drawings over here. 6 degrees. So this would be root 3. This would be 2. And that would be, I'm sorry, I made a mistake. I'm not even thinking. Okay, something like that. Now, what's the slope of that? Well, it's negative. It's a negative slope. And what's the slope of that? Well, it's a negative √3 over 1. So y would equal minus √3 x. Put a box in it. Let's go to the answer key. Let's see how we did. Yep, I'm looking at it. I feel good about that. Let's go to number 6. Relatively simple question so far. Have not been stressed out too much. Haven't used any technology so far. What's number 7? And I'll read it to you. Oh, I'm sorry, number 6. Maybe I got scared. 6 says, convert the polar equation to rectangular form. So you got the r equals 1 plus sine theta. Well, the first thing I'd like to do is just simply, maybe get rid of the fraction in it. Now, what would you get over here? R plus r sine theta equals 1. All right. So someone says, what are you going to do now? Well, hopefully you want to go back over your notes and maybe familiarize yourself with the relationship. And I'm going to write a few down for you. So I know that x squared plus y squared is equal to r squared. All right. And I'll write another one down for you. I'm going to write down the sine of theta is going to be y over r, or r sine theta is equal to y. I'm also going to write down cosine of theta is equal to x over r, or r cosine theta is equal to x. Well, let's go back over here. And I know it looks difficult, but one thing I do notice is I do know what this is. What's r sine theta? It's y. I'll write that down for you. So we get r plus y is equal to 1. Well, I got troubles now. I'll tell you what the trouble is. I'm mixing things. I got the Cartesian, the y in it, with the polar, the r in it. So I need to get another relationship to get rid of that r in terms of x and y. And write this down for you. So r equals 1 minus y. I'm going to square both sides. You may wonder why I would do that. I'm going to do that because I know what r squared is. And what do you get on the other side? You would get 1 minus 2y. I'm squaring both sides, plus y squared. Well, what's r squared? It's x squared plus y squared is equal to 1 minus 2y plus y squared. All right, I'm going to say I've done it. And if you put a box in this over here, you've done a great job. But I want to point out, I would like to simplify this guy. All right. So what happens over here? Subtract y squared from both sides. What do you get? X squared equals 1 minus 2y. I'm going to rearrange this. 2y equals 1 minus x squared. And I'm going to continue to arrange it. And what do you get? Y equals 1 minus x squared over 2. Okay, so I'm going to claim both of those are good answers. I want to claim the second one is a little bit easier for me. I'll tell you why. I recognize this thing as being a parabola now. What's this thing over here? It's a parabola. All right, let's see if we've done that right. And I noticed I wrote down something a little bit different than what I wrote down. What they wrote down? They wrote this one down. That's fine. Well, there are 2y equals 1 minus x squared. It's really the same story. Let's go to number 7. And let's see how we're going to approach this problem over here. Number 7. What does it say? It says graph the polar equation. Let me write this down. R squared is equal to 4 sine theta. All right. So it's not easy. I'm not saying it's going to be easy for you, but one of the things you could do, and certainly when I say you could do it, I'm not saying it's going to help you, but you could at least try. Certainly, I know what r squared is. What is it going to be? It's x squared plus y squared. And then I'd get, 4 sine theta. And I'm going to be honest with you, this didn't really help me. But what you could do now is multiply both sides by r. What do you get? R, x squared plus y squared is equal to 4r sine theta. All right. Now, someone says, why would you have done that? Because I recognize this guy. And what would you get? R, x squared plus y squared equals 4. And what's r sine theta? Well, I guess we just did that. It's y. Here's the problem. This seems like it's going on and on and on, and I'm not going to go anywhere with it. However, because, since the first thing you did was you got rid of the r squared, then you had a mixture of polar with Cartesian, and I'm still getting a mixture of polar and Cartesian. So I'm gonna, maybe call it, let me just get rid of this thing over here. I'm gonna erase this because really I'm in an endless loop, all right? Not endless, I could certainly get rid of it. Okay, so what I'm gonna claim over here, what we'd like you to do, all right, at least initially, is struggle with creating a table, all right? And when I say struggle with creating a table, what are you doing over here? The table is gonna have an R in it and a theta in it, and you're gonna pick thetas and R's. But I'm gonna come back to this one over here, and I wanna go through using Wolfram alpha. We'll come back to that. Whoops, alpha. We'll come back. All right. So I'm going to go to the next question. Next question says graph it, and that's number 8, by the way. And again, my understanding is I'm going to still use Wolfram alpha, and we'll go through that with you. It's the easiest software for you guys to use. All right. Let me go to number 9. Number 9, same thing. I'm going to use Wolfram, and I'll come back to it. Alpha. I'm going to do it. All right. And keep going here. And these are tough graphs. I realize that. I think that was it. Let me make sure of that. Yeah, I think I'm good. I'm going to go Wolfram alpha. Right, I'm going to put this on the side. And I'm going to switch screens. And I'm going to open up a web browser. I'm going to go to Wolfram alpha. Whoops. Pull on the side. And again, I want to point out what we're trying to do. And yeah, you have to learn how to do this, by the way. By the way, we did 6. I didn't ask to graph it. It just, convert to polar. I did say it was going to turn out to be a parabola. Let me put that down for you, though. All right. So I'm gonna type in R. I'm gonna say graph it. See how it does. Graph R equals 1 divide by, yes, parentheses must be used, 1 plus sine. Now someone's gonna say, where's the theta? Just type it in. Let's see what happens. Who knows? Maybe you can't do it. No, there it is. What is it? It's a parabola, as we discussed. We wrote that down for you before, all right? Now, granted, it may not be the best picture, but they did graph it out. Let me do the next one, which is number 7. R squared equals 4 star sine theta. And again, I don't know where theta is on the keyboard. Actually, it's there for you, but don't worry about it. Type in the word theta. Let's do that. And let's see what it gives us a picture of. I'm going to scroll up. Not bad. We got the picture of it. All right. Let's do number, let's just do number 8, right? These are really easy to do. R is 8 minus secant theta. See what it gives us. Wow, that's a really tough looking curve over there. All right. I want to point out these pictures are given to me over here as well. All right. And let's just do number 9. And I hope you appreciate the ease of using software. At least Wolfram alpha, it's pretty easy. And that's R equals 4, parentheses, 1 minus 2, star sine theta. And let's see what happens. And this will be a picture as well. Wow, look at that. Yeah, pretty quickly. All right. All right, I'm going to close that out. Again, Wolfram's really simple to use. You want to learn how to use it. All right, you really do. So I want to go back to the notes. I just closed them too. Sorry about that. Got to get back to my notes. I'm going to talk about using Sage now. Right, so let me open it up. I'm going to use it from the terminal. Again, for students who don't want to use Sage from a computer terminal, this is typically on a lot of machines. Terminals are going to be used to do most computations. I actually tend to use terminals for a lot of work. However, you can also go to CoCalc, which is on the web. That's at sagemath.org, and you can do this using sagemath.org. I also want to point out, if you're running a computer that has software installed on it, for example, let me just briefly go through this with you. And this is an application called Grapher. One thing nice about Grapher is it has examples down for you to look at, example code. So for example, I mean, you could look at parametric curves. That's an example. Let me go through that with you. It opens up examples how parametric curves are put in. Let me close that out. There's other examples down. I want to point out, if you look at the examples, sometimes you're not familiar with, but that doesn't matter. You're looking at it, I guess, let me look at this one over here. We haven't even discussed that one yet, have we? Right, something interesting over there. And you can go to a bunch of those things, all right? I don't want to save that. You could also do things that you're maybe going to do in the future, 3D examples. One thing nice about commercial software, we can do interesting things with it. Okay, you can play around with that. All right, I may come back to that later, but I want to do Sage. Let's see, 1 + 1, see how it does. All right, I'm going to reset. Look at the code. All right, choose a variable. Write this over here, var. We talked about T before, right? Typically as a parameter. And I'm going to see how it does this. So it really looks tough to me, but let's type this in. I'm copying, by the way. Put that down for you. Pull it over so you can see it. What is going to be parametric plot? We've seen this one in the notes before, right? What Sage is doing now, it's creating what's called a graphic primitive. It's launching a server. It needs to do that computation, and it does that. Now, you should recognize that curve. We did that in class, by the way. Hope you remembered me doing that in class, by the way. All right, so that's done. All right, that's nice to know. Let me type in the next line of code, which X, Y is going to be some variables I have over here. Oops. Just typing, that's all I'm doing. All right. All right, a long line of code. Let me see if I can do this. Implicit plot. And I'll put this one down for you. Implicit, what is it doing? I guess that's the original curve we try to show you in class, right? How difficult they are to do. And what's going to happen here, it's going to plot it out. We did that one in class as well. I want to point out the X and Y axis are not being displayed over here, just the graph, right? The X axis would be here. The Y axis would be over here. We actually did that graph in class with the first graph. All right, let's do this one over here now. I'm going to go back to my Sage terminal, and I'm going to type in theta as a variable, and that variable is going to be called theta. So I can use multiple letters now, so that is theta, so we did in Wolfram. And a longer lines goes in, maybe I could type this one in. No, I'll just copy it, and we'll talk about it. Did that. And let's do this one over here, see what happens. Tough polar curve to plot, by the way. Machines are not going to have trouble with it. Did it right over there. All right, not bad. We can do those. All right, have we done that stuff in the problem sets? Of course we have. All right, just go back over the notes. You're free to use the software. I do want to recommend a lot of students have to learn how to use software. When you take an exam, though, you notice that when I did the problem set, most of the problems were done by hand. It wasn't until I got to problem number 7 that I went to technology. So the last 3 questions, 7, 8, and 9, I used technology to do that. But the remaining questions were all done by hand. Hopefully you've mastered that material and you feel comfortable not only doing simple things by hand, but using technology to do more complicated things. Thank you.